I'll try making this video because I was doing so many interesting setups to check this for squareness and stuff like that. And I thought maybe it'd be an interesting video. But a good part of the reason for making it is to show this system of mounting a post by drilling through your surface plate and mounting a post and putting your indicator thing on there that goes up and down, and also this squaring thing that goes on there and also goes up and down. So I'll give it a try, but a lot of the stuff I have to be using two hands like to hold this, and so I don't know how I'll mount the camera. So if you see some goofy angles, that's why. Another reason for making this video is that this old vintage stuff, like Anton opened in 1930, this probably was made during the zone of World War II or the Depression. But at any rate, their tolerances and their equipment just simply didn't match what we have today. And so when we make things like for molds, they may be within a tenth. And so to them, maybe a thousandth was considered close. And so some of the things on this to look at, like if you're a beginner or hobbyist, is first of all, like this round part, is that centered on the block? How about the block itself? Is it square? Okay, if you tweak things and fix things, what do you do first? Square it up first, or fix this first or that first? So what? So that's, that's part of the reason for the video. And also with these, for instance, if you get Chinese stuff, that you need to true it up. So this would be good for how to do it, how to check it, how correct decisions, how to check things, Okay, that's it. Okay, the first decision, where to start, what to check, is, okay, this goes in here. Okay, so everything is based on this. That's your starting point. That's your reference. And so the first thing I'll do is I'll indicate here and here to make sure that this is dead level. And then next, I'll check for squareness, because if you have to fix it, the first thing you have to do is square it up by a thousandths or a few tenths, and then dust it off and make it perfect, and then you start doing your other stuff. Okay, so the first thing is I'll do this. It's quick, it's easy. Then I'll check for squareness. And then any other thing that I tweak and adjust, that fixing, grinding to square, dead nuts, that has to be done first. And so the decision is to check this first, not this, because I come up with all kinds of goofy readings on this, and it turns out that this has to be squared. And so then I dust it off and square it up. Well, now I put this back in here and check it for being centered. Well, now it's changed because I've changed this now that I've adjusted the squareness. So you see what I mean? You got to pick the correct order of how to check and what to fix first. Okay, now some of this, the intent is not really for you to see the indicator perfect. It won't be possible. So, okay, so the very first thing, this round, well, I can't change that. That's the main part of their manufacturing, was this. I can't change that. Therefore, everything else follows from this. So let's check this first. Okay, go back and forth, and set the indicator's dead nut 0. Okay, now I rotate it. Okay, it's shy, 9/10. It's shy 9/10. So in other words, this is thin, and this other end would be thick. So the first thing that I will do is set it on the surface grinder and take 0 on one side, and it'll be 9/10. In other words, I'll take 9/10 off of here and taper it out to 0. You see what I'm saying? That's the first thing. Okay, now that that surface is established on the surface grinder and that this is brought to zero, to where they're both zero, okay, now the squareness has to be fixed based upon this back surface. Okay, so I'll show you how to check squareness. But anyway, do you see what I'm saying about this round? That round is put in there on a slope. Almost 1/1000th is 9/10 of a slope from one end to the other. Can't have that. No, you can't have that. It has to be made right. Okay, so let's check the squareness. Okay, so now I swing this into place. This, by the way, it does not sit on the surface plate. Actually, it should be gapped up like whatever, 10, 20 thousandths. It makes a difference. So don't look at this like this is supposed to be in contact with the surface plate. Also, this end here is an invisible huge radius that I programmed in. I think a 20-inch radius. Also, the bottom of this is chamfered and relieved so that when you see me moving the block, it's not touching right down on the surface. It's in contact maybe 40 thousandths above. Okay, so I'll swing that into place and tighten it down. Tighten down on the shaft a little bit. So now I'll be going like that against this big radius. Okay, so I'm going to get the indicator into position. Okay, you may be able to see the indicator on this one. Okay, so let's check for squareness. Now see how I'm rolling it, I'm moving along kind of in a slicing motion on that radius. See the indicator? It's coming up on 0. Now, the purpose of the video isn't to like set up a 10th indicator and show you that. Okay, so if I flip it over, you see there? So it's a little bit off. Now, by me standing it on the ends, these narrow ends, okay, that's amplifying any out of squareness. Anyway, see it? See it's 0? And then, see, the video is to show this device, how useful they are. So see there? Okay, now if I had set this down on this surface and then put the indicator here, I could go like that, and of course it'd look dead, even more dead nuts. But by me doing it the way I did, it amplified it, just for the purpose of the video. Okay, now, okay, so let's call that square. So the next thing, how do we know that this is centered on this block, this big round part? How do we check that? I can set up like this, come down with my indicator up against here, and go like this, and then flip it, and repeat to get a feel for if that's centered. But is that really right to do that? Not really, and I'll tell you why. Okay, because this goes in there. Okay, so the proper way to check it is to indicate across this diameter with it in the round. Okay, not to check components and go by what they say. If it's going to be used assembled, well then you make everything perfect, yes, but then you assemble it and you check that. Okay, so let's do that. This part's going to be tricky because I have to do this two-handed. Okay, here we go. Now, I'll be holding this up on edge with that thing in there. See, so I'm going to put that on its edge. I'm holding in with both hands as hard as I can. Oops, sorry about the shake because the camera's sitting up high on a box. Okay, now I'm I'm squeezing in. I don't know if the camera can see it, but I'm holding it in a position. And now it's come across there. There, see? We'll call it 0. I'll change it a little bit. Here again, the purpose is to document the accuracy of this block. Okay, there's 0. And so now let's go side to side and see if there's taper this way. It looks pretty good. Okay. Now let's flip it. Now you saw that it was out a little bit. Okay, now this is the other side in the block to which it's mated with. Okay. Let's see there. Very close to 0. And so the center part is pretty centered. The round slot going through there is somewhat centered in the middle. So now let's look at the cint. It's very close. Very close. Very close. Very close. Okay, let's flip it over. I want to look again what was going on that other side. Okay, I'm squeezing, I'm holding hard. It's very close. Very close. Oops. And very close. Okay, it was the way I was gripping it. Okay, therefore, I make the determination that this round is in there tapered, 9/10 difference from one end to the other, but that it is centered perfectly. Okay, so we check squareness and we check that. Let me think next. Oh, I want to show about the V. Okay, now this goes, that goes in there. That's what I was just fitting in there. Okay, so now the question is, what about this V? Is this V centered in this? So everything is based on the round. So is this V centered in the round? Okay, let's check that next. I'll show you how we do that. Let me get it ready. Okay, so I'm checking this V to see if it's centered or if I have to true it up on the surface grinder. And so these blocks, everything is stoned off beyond belief. Trust me. So don't be thinking possible burrs or... Okay, so I put the one side of the V on there, like that. See how it is? Okay. Let's run it under there. Can you see the indicator? Okay. See? 0. 0. You see, going side to side like this also tells me if that B, the V is in there tapered, you know, where it's tilted goofy. Okay, now let's flip it. Let's flip it. Now I'm going to put it on this one. Slide it across there. Now let's see where it is. This is going to tell us if that V is centered or not. It's a mile off. Okay, now I already knew it because I'd already checked it before I did this video. But you see there, it's about 2 6/10. 2 2 6/10. So see how that was heavy? That was heavy. And so that means that this surface upon which it was resting, I have to come down 2 6/10. Actually, it'll be 3 6/10 because see this surface here with some dings on it from all of its use over the years? I'm going to take 1/1000 off of that to clean it up. So then that means come down 1/1000 more. In other words, well, you could do the math. And then afterwards, I'll do the same thing. This setup will be on the surface plate in the shop. Then I'll do the same thing, just like this, after I clean it up, you know, because you dress the wheel and okay, and then I'll go over and I'll go like that. Oh, 2/10 heavy. Okay, now you think I'm not going to put it back on the grinder and do the 2/10? You bet I will. But anyway, the V will be dead nuts centered. So there you go. That's most of it. And so notice that there was, I showed about using this. Also order of operations, that everything is based on this, and so you go from this and then reverse engineer it backwards, not the other way. You don't set this up and start tweaking this V and messing with this, when in fact this is the starting point. Let's see if there's any other thing before let me think. I'm going to shut the video off and think. The one other thing I wanted to show is that after I true up that V, well, the main block and then the V, and get everything square and dead nuts, okay, then now this V that goes in there, the insert that goes in there for doing level stuff, that will be off. And so I'll bolt it in there. I put 3 screws in to hold it in, and then I'll dust off the top. I'll set it perfectly level, just like what I'm doing now, to where it indicates from side to side level based on these things, these edges. And then this here will be goofy because I will have dusted off the sides of the V. Okay, so that will be the final thing, is that I'll put in these screws, tighten them down real good, and set it in there, level it up, and dust off the top. Dead nuts. Dead nuts. So I guess the moral of the story, when you check these devices, don't think that if somebody else made them or they came from somewhere else, what? They knew what they were doing and they're perfect, but you don't? You don't know what you're doing? No, a lot of this stuff you can make it better than when it was new. Yeah, don't always assume the other guy or the other factory, they're the tool gods, and because that's the way that it was manufactured, that they're God and you're nothing. That's not the way it works. Most of this stuff you can true it up and make it better, and make your own stuff. You make your own stuff and you grind it square to, you know, 1/2. Well, most of this stuff, especially this vintage stuff, it doesn't come that way. They could have done it, but they would charge 4 times more, and then nobody would buy it. Okay, I think that's the end. I think that'll be the final one.